having me along. It's great to see so many people attending events such as this. I'm just going to give you a quick snapshot on two projects that I was lead investigator for that have just recently been completed last year. The first of these was an NCAR, Settlements and Infrastructure Project, and the project aimed to develop tools that would allow local governments to translate the effects of climate change on assets into their strategic and operational, financial and asset management plans. Adam Gray touched on this and the next project that I'll be talking about, so just an opportunity to let you know a little more about the project itself and the findings. The report was released by NCAR and is available on their website. And I'll also just draw your attention to the organisations that were involved in the project. It was a collaborative project with local government association, the universities, and IPWEA, the Institute of Planners and Water Engineers Australia, and it had a very strong practical focus on delivering outputs that would be usable within existing systems that councils were familiar with. So the context of the study was that Australia's 560 local government authorities manage assets of about $212 billion. I think that value has increased since that study was undertaken. Many of these have a lifespan that will be greater than 50 years and so will be affected by climate change. And currently there are fairly unquantified values associated with how we might cost the impacts and maintenance of these assets into the future. So we did an assessment of the value of assets for local governments. An example here from South Australia. You can see that roads are by far the largest asset class and are obviously an extensive network that are exposed to the climate across the country. We worked with 10 case study council areas across southern Australia who were closely involved and engaged in the process and attended a number of meetings to identify the key concerns that they had with managing that road asset. The outputs from the project included a process for identifying climate change risks on the assets. We developed a financial simulation model that was based on the Australian Road Research Board engineering equations that allowed us to quantify what the impacts of climate change will be on the road infrastructure that we considered and what the costs of maintaining and repairing roads would be under a climate change scenario. We then modified the existing IPWEA NAMS Plus tool, which is an asset management tool that is used by councils nationally to include the outputs from the financial model and the climate change scenarios that we can run through it. And then we also produce some product support and training tools, the final report to NCAR, and there's conference papers and a journal paper currently under assessment. So the little table there to your right just gives you an idea of the steps that we would work through when we're using this tool. We would select your council, select your climate change emissions scenario and the year that you want to do the projection for, input the annual temperatures and changes in rainfall, select your asset type, and we have 3 road classes in there: asphalt or hot mix roads, spray sealed roads and unsealed roads. Input the engineering parameters, the costs associated with maintaining those roads, and run the model. And the output is provided in a distribution format, you can see on the bottom of the slide, and also summary tables. This gives you a little snapshot of the results when we did a high emissions 2,100 year model run. In all cases, for the case study councils that we looked at, it showed that there would be an increase in the useful life of the roads that we assessed and a corresponding decrease in maintenance cost. And that was primarily driven by the fact for most of those areas in southern Australia, as we've heard, it's likely to be getting drier and rainfall has a significant effect on the useful life of a road. I should note though here that extreme events were not included in the assessment, and obviously that's a completely different situation when we look at that. The second project was the Coastal Adaptation Decision Support Pathways project. Again, a wide range of stakeholders that were involved in that. It was submitted in August last year and will be released soon by the department. In this, we were looking at developing a climate change decision support framework and again some financial software that would help councils work out the costs of associating or identifying and planning for adaptation in the coastal zone. So sea level rise, as we know, is going to exacerbate coastal inundation and erosion along the coastline. There is going to be an associated cost and legal implications with that, and local government at this stage are not necessarily clear about what those implications and costs would be, and we wanted to develop a tool that would aid them in that process. We used two council areas in South Australia that already had information about inundation and erosion available, and again we developed a financial simulation model that linked in with erosion and inundation models in conjunction with the Coastal Protection Board here in South Australia. We developed a decision tree which would help councils step through the process of identifying which areas in their councils are at risk, what the assets that would be at risk were, and what the damage costs from these events might be, and then how would they identify and cost a range of different options. So the financial tool looked at options for retreat, adapt, defend or defer the decision on what to do, and included hard and soft engineering options. So what would be the cost of building a seawall, for example, as opposed to modifying the existing infrastructure and adapting it in its current state. As I said, the report should be released soon by the Department of Climate Change and Energy Efficiency. And some example outputs from the project are here shown on the right, the decision map. This is the first step in the decision mapping process where you assess your climate risk and the likely impacts from coastal erosion or inundation. The model there shown to the top left just gives you an idea of the complexity of pulling together all the components of coastal inundation and erosion when you're putting them into a quantified model. And the bottom left-hand corner shows you some of the spreadsheet tools that were developed to enable councils to collect the information that's necessary to run a model like this. Thank you.